time and space complexity. Okay, so first in this video we come to understand that what is algorithm, and when your algorithm is being developed, after that we learn the importance of time complexity and next space complexity, and symbolic notations what we use for finding the time complexity and space complexity. Now we understand worst cases, best case, and what is average case, and after that we learn the algorithm efficiency, and in different cases how we measure the time complexity and space complexity. So let us see here. First, what is an algorithm? So an algorithm is a formally defined procedure for performing some calculation, or else there is one more definition. An algorithm provides a blueprint to write a program to solve a particular problem. Example, if you want to construct a building, before that we want to have a plan. So as per the plan, the building is been constructed. Similarly, if you have a blueprint, according to the blueprint, a program is been developed. So a blueprint is now nothing but like a algorithm, and according to that algorithm, a program is being developed for solving any particular problem here. Okay, now you understand about what is algorithm. So in developing the algorithm, these are the symbols which we use for developing. So these are the symbols. I hope you learn in the earlier classes only, but here I have been showing you that what symbols we use for developing an algorithm. And next, after developing an algorithm, what is our target is that whatever the algorithms you have been developed, you can implement that algorithm in a program with using any different languages. But whatever the programming language you have been used for developing an algorithm, the program should take less memory and less time here. So that is our target here. So how you can say which program is being taken less time and less memory? So here we want to find out the time and space complexity of each and every program here. So first we understand what is first actually time complexity. So a time complexity of an algorithm is basically the running time of a program. Suppose if you are having 4 programs, we want to take the each and every programming running time. So one program, if you are having 5 seconds, if the second program having 10 seconds, the third program having 3 seconds, and the fourth program having 6 seconds. Now we take the third program having 3 seconds. So like that, so we measure the time of each and every program. And next, a space complexity. A space complexity of an algorithm is the amount of computer memory that is required during the execution of your program. So not only the time, and while you are executing a program, at that time how much amount of memory is being using, that is also to be considered. So if you want to understand clearly, in other words, the number of machine instructions which a program executes is called its time complexity. And the space needed by a program for input, processing and outputs is called space complexity. Okay, now I hope you understand that what is time complexity and what is space complexity. So next, if you want to calculate the time and space complexity, symbolically what are the notations we used here is that we use big O notation, and the other one is big omega notation and big theta notation. So this big O notation is used for calculating the worst case time complexity of an algorithm. Now omega it is used to measure the best case time complexity. Now theta, it describes the average case complexity. Now it means this big O notation is used for worst case, big omega notation is used for best case, and big theta notation is used for average case. Okay, so what is best case, worst case and average case? So worst case is a function which performs the maximum number of steps on input data of size n. Suppose here, if you take an array with 10 elements, if you want to find any particular element in an array, so what is the maximum, what is the worst case of time it takes? It takes up to 9 elements. It means if you want to search for an element 0, it's to start from searching 1, 2, 3, 4. Worstly, it is going to take how much time here? 9 seconds. 9 elements to be searched. So each and every element searching take 1 second. So totally how much time it takes? 9 seconds. So worst case is what? 9 seconds. Suppose if your element is found in second place. Now at the second, the best case is what now? 2 here. And average how much totally it is going to take here? Having 10 elements when divided by 2, we get a 5 seconds average time. Okay, so like that, the worst case, average case, and the best case is being calculated here. Okay, I hope now you understand what is worst case, average case, and best case. So these are symbolic some definitions, and for examples for linear search is being given you on the screen here. Okay, next, how to express the time and space complexity. The time and space complexity can be expressed using a function what? F of n. Suppose if you want to calculate any time, the time is being expressed with the function what? F of n, and where n is the input size of the given instance of a problem being solved. So here, if you want to express the complexity, we require what? We want to predict the rate of growth of complexity as the input size of the problem increases. So there are multiple algorithms to find a solution to a given problem, and we need to find the algorithm that is most efficient. I already said that there are number of solutions for an algorithms, and we want to find that which algorithm is best and which program is best. So here let us see now how to find the efficiency of an algorithm. Suppose if a function is linear without any loop or recursion, the efficiency of that algorithm or the running time of that algorithm can be given as the number of instructions it contains. Suppose in a program, if I am having 5 instructions, and if every instruction is taking 1 second, then the total time it takes how many? 5 seconds. Suppose if my program contains 10 instructions, then it takes 10 seconds. It means now without any loops or any recursions, if you are going on executing the statements sequentially one after the other, how many instructions are there? That many seconds have been taken. So each and every instruction, if you take 1 second, that many seconds have been taken for executing your program. So suppose if you are having 10 instructions, it takes how many? 10 seconds. That is the meaning of this point here. Now if an algorithm contains a loop, so previously without any loops and recursions, so step by step, if the statements are going on executing, so if 10 instructions are there, it taking 10 seconds. If the 5 instructions are there, 5 seconds. But if you have any loops in your programming, then the efficiency of that algorithm may vary depending on the number of loops. It means suppose in your programming, if you have a loops, then the variation, there will be a variations between the programs. Okay, so and the runtime of each loop in the algorithm will be also different. Suppose a program 1 is there, and a program 2 is there, and a program 3 is there. Now in each and every program you have some for loops. So when you have for loops in each and every program, there may be a variations in each and every program, because based on the loops the time is being calculated. So here we understood one point is that if you don't have any for loops or recursions, then the time is being measured simply. But when you have some number of loops in your programming, the time is being going on changing. It means in one algorithm the time taken is being different, and the second another algorithm also the time taken is different, and in the third algorithm also the time taken is different. It is totally depend on the number of loops what you are using in each and every program. So let us see now in which different cases the time is being having changes. So when you have a different cases in which loops, suppose if you are having loops for loop or any loops, then how the variations are been found. So some of the cases we are given. One is linear loop, one is logarithmic loop, and the other one is nested loop, and the other one is what? Linear logarithmic loop, and the other one is quadratic loop, and the other one is what? Dependent quadratic loop here. Let us see individually each and every loop here. So what is linear loop? To calculate the efficiency of an algorithm that has a single loop. Suppose if you are having only single for loop, okay, and we need to first determine the number of times the statement in the loop will be executed. Suppose here, as per this for loop, it is having how many times it is going to execute up to 100. I started index from 0 and it starts endings up to 99, but every time it is been incremented by 1. It means if I'm having n equal to 100, then it takes how many seconds now? 100 seconds. Suppose if I am incremented by 2, now when I am having n instruction n equal to 100, then what happened here? It is going to execute how many times? N by 2. It is nothing but 50 times here, because it has been every time it has been incremented by 2. It means half of the time it has been executing. Now we observed that there is a difference between these two for loops. See, as per this single for loop, it is been executing how many seconds? How many times? 100 times. But as per this for loop, it is been executing how many times? 50 times. Now where you have been getting here? Where in your addition or division you are going to get here. Okay, so this type of loop comes under what? Linear loop here. So in a linear loop, when you have the additions or when you have the subtractions in your for loop, then we go for linear loop, and it is represented as a function f of n equal to n, or else f of n equal to n by 2 here. Okay, now coming to the logarithm loop. So in the logarithm loop, the loop controlling variable is either multiplied or divided during the iteration. So previously in for loop we used addition incremented by 1 and 2 here. So when you have in a for loop, when you have such type of like multiplications or divisions, then we go for a logarithm loop. So in the logarithm loop, it is represented with f of n equal to log of n here. So consider the first for loop in which the loop controlling variable I is multiplied by 2 here. Now see here, in this iteration, suppose if you don't think about this, and if you think simply increment by 1, it takes how much time? 1000 times. But now here I is being multiplied by 2 here. It means the first iteration, when I multiply, the value is 2, and once if you multiply the second time, the value is becoming as 4, and next time when you multiply, the value is becoming as 8. Now what happening here? Every time the value is being doubled, 2, 4, 8. Next time it becomes as 16. Now what happened here? How many times it is going on? So here the loop will be executed only 10 times and not 1000 times, because in each iteration the value I is doubled. Now consider that second loop here, which is loop controlling variable, divided by 2. Now consider this 2 loop. In this, it is being divided by 2 here. In this case also the loop will be executed how much time? 10 times. Okay, so now what you observe here is that in this multiplication and in this division, the loops is being executing how many times here? 10 times only. But actually the linear loop, if you go for it, it should be executed 1000 times. But see here, when in a for loop, when you use any multiplications or any divisions, then we consider these type of loops under logarithm loop here. So how we represent this a function f of n is equal to log of n here. Okay, so next when you come up to previously, we have seen only single for loops. Suppose if you have one for loop and another for loop in one loop, we call as nested loop. Nested loop means what? Loops that contains loops are known as nested loop. If you one loop is there in another loop, then it comes under nested loop. In order to analyze the nested loop, we need to determine the number of iterations each loop completes. Suppose now only one for loop we have been calculated. Suppose in one for loop, if you are having addition or subtraction, we are being taking that loop, considering that loop as linear loop. In a loop, if you are having multiplication or division, we are considering that loop as logarithm loop. Now here, if a loop having sub loops, it's nothing but we referred as nested loop. But in this nested loop, there is so many variation. See here, the total is then obtained as a product of the number of iterations in the linear loop and the number of iterations in the outer loop. So inner loop and outer loop. Suppose you have, let us see now clearly, in the nested loop we have different loops here. We are going to start linear logarithmic, quadratic, and dependent quadratic. So let us see clearly each and every nested loop. So one nested loop here, example, we are having one for loop and in that another loop, but this nested loop comes under linear logarithmic. Linear means if you have addition and subtraction, it is linear. If you have multiplication and division, it is a logarithmic. Now observe that in one for loop we are having increment, it's nothing but 1 increment, and it's an addition. In the other for loop we are having multiplication. So here now what understood that in this nested loop, one loop is being executing 10 times and the other loop is going to execute how much times here? See, j divided by 2. It means now first time 2, next time 4, next time 8. It means only 3 times it has been going on execute. So now here the number of iterations in the inner loop is log of 10. So when you execute each and every loop in this, it is taken as what? Log of 10. The inner loop is controlled by the outer loop which iterates 10 times. So here every time the loop is been, suppose the loop is 1, it has been repeated how many times? 3 times. Now when the iteration is 2, again it has been executing how many times? 3 times. When the loop in outer loop is 3, now the inner loop is going to execute how many times? 3 times. Like that. So if the outer loop is being executing 10 times, but every time the inner loop is been executing commonly 3 times. So that's why it is been said as log 10. So therefore, according to the formula, the number of iterations of this code can be given as 10 log 10. Okay, 10 log 10. In more general term, the efficiency of such loops can be given as f of n equal to n log n here. This is the formula what we use for this. Okay, f of n equal to n log n here. Next, what is quadratic loop? So here, in quadratic loop, there is no division or multiplication. See here, in this outer loop we are having addition, in the inner loop we are also having addition. Suppose if you have outer loop is n and the inner loop is also having n, now the inner loop is executing n times, the outer loop is also executing n times. It means n into n, how many times it is going to execute? N square. So it is been symbolically represented as f of n equal to n square. Okay, so you understand now what is quadratic loop here. Next, dependent quadratic loop. See here, now previously every for loop is different, but here in this for loop the inner for loop is totally dependent on outer loop. See here, now j is less than or equal to I. It means now it is the I value is about outer loop. Now the inner loop is being dependent on outer loop. Like that, suppose when I equal to 0, now j is being executed how many times? 0 and 1 time. Now when I equal to 1, it is been executed 0 comma 1. Okay, sorry, it is been executed 0 time and here executed 1 time. 1, next is 2 times, next is 3 times, like that. Here see, so for first iteration it is been executing 1 time, second iteration 2 times, third iteration 3 times, fourth iteration 4 times, like that it is going on executing. So how many? Totally 55 times it is being going executing. So both so it is represented as a formula that f of n equal to n of n plus 1 by 2 here. So this is the formulatic representation of a dependent quadratic loop here. What is that? F of n equal to n of n plus 1 by 2 here. Okay, so a small examples that how to calculate the time here. Let us see here a small some instructions are being given. A equal to a plus b is one instruction. It has been taken as one constant c1, and this for loop is been having increment. It comes under linear loop. So I have been represented as c2 c constant with n times. Now this also loop executed n times. This is also with constant how much? C3. C3 is one constant. So now if I want to totally calculate the time here, c1 plus c2 plus n plus c3 n here. Totally how many times? Order of n here is the way we are going to calculate. So next, if you go for here, it is like a quadratic loop. So n times for one loop, n times for loop, n into n how much? N square here. So this is small example that how we calculate the time. So here we know that so many algorithms having for sorting. So for every sorting algorithm, this is the formula formula what we use here. So for best case and for average and for worst case. So these are given here, best case and average case and worst case of time complexity. Okay, and if you want to calculate the space also, so let us see now space, how much memory it is taken. Suppose if I take for every integer we take 2 bytes in your memory, but assuming here as 4 bytes here. So how many variables are the 1, 2, 3, 4 variables? Now 4 into how many bytes? 4 bytes. And when you return some value again, it is going to give the integer value is at 4 bytes. So totally how many bytes it is going to take? 20 bytes. Okay, so here now you understand how to find the space complexity also. So overall from this video, what you understand here, what is time and what is space complexity, and what are the notations you are used to find, and how to find the efficiency of the algorithm, and also we have seen the examples here. Okay, thank you, all the best, and have a nice day here.